Now it's time for vector components. The big new deal here is we are finally going to introduce coordinate systems. So here I have a vector, A. And here I've laid down what I call a coordinate system. And the typical way to lay down a coordinate system on a blackboard or a whiteboard or a piece of paper is to have x going to the right and y going up. That's the standard way. Don't get too hung up on it. Sometimes it might be nice to have x going left. Sometimes it might be nice to have y going down. Don't get too hung up on it. It's standard, though, to have x going right and y going up. If I've drawn it in this standard way, I'm going to now show you what the components of A turn out to be. I'm going to define them and show you what they are. What we call the x component of A is what you get when you drop a line down perpendicularly to the x-axis and then you measure that distance. That's what we mean by A sub x. It's whatever the shadow is of A. If I had a light up here, way up there, it's way up there and shining perpendicular to the x-axis. It's whatever shadow A casts on the x-axis. And similarly, if I had a light way off to the right, and I saw that was like shining perpendicularly to the y-axis, whatever shadow that A casts on the y-axis, I measure that's length, and that's what I call A sub y. Now here's something nice. Suppose I want to bring in second vector into the problem. So here's vector B. Okay, now I'm going to cast its shadow. Okay, so here's something kind of cool. Remember that if I define the vector C, which is equal to A plus B, notice how I've lined these up here. The tail of B is already sitting on the head of A. So in this diagram here, I can actually very easily construct C. And notice the shadow of C is this whole thing right here. That would be C sub x. And if I cast the shadow that way onto this axis, the shadow of C in that direction, that's C sub y. And notice that the shadow, C sub y, is got the length, which is just A sub y and B sub y. And the shadow, C sub x, is just A sub x plus B sub x. Okay? So that means that all these new quantities that we've introduced, A sub x, B sub x, C sub x, A sub y, B sub y, C sub y, they obey ax plus bx, the shadow of A plus the shadow of B on the x-axis, is the shadow of C on the x-axis. And the shadow of A on the y-axis plus the shadow of B on the y-axis is the shadow of C on the y-axis. So we've just learned from the rule for vector addition and the definition of a vector's components, we've learned that the components add like that. Now here's a couple things I want to emphasize. One, this is a vector. The length of its shadow projected onto the x-axis, which we call d sub x, is not a vector. Notice there's no hat on it, no vector sign on it. It's d sub x, it's a number, it's a length. Whereas d was a vector. These are numbers, this is a vector. So don't be drawing vector signs over your vector components. The y component of d is a scalar. It's a number, maybe with units, but it's a number. That's one thing. A second thing I wanted to emphasize was, notice that where the tail was of D was not critical here. It's the length of the shadow, and if the tail isn't at the origin, it's still the length of the shadow. It's not this distance. It is not that distance. It's the length of the shadow, which is that distance. Okay. Now I want to show you something else kind of cool you can do with vectors. Remember that business where we talked about them being a length and a direction? So here's D again, and here's my coordinate axis. And a really common thing is to measure an angle of a vector from the x-axis. So here I've drawn the x-axis. Here I've drawn a line that's parallel to the x-axis. Here's the vector D right here, and this angle theta is therefore the angle from the x-axis. Now, let's suppose that this vector D here, which I noticed I forgot to have my arrow sign over it, but I just fixed it. This vector D here, let's give it a length. Let's give it a length, and let's say that the length of D is little d. Okay, now we can ask ourselves, using a little trig, what is d sub x? Now, opposite over hypotenuse and adjacent over hypotenuse are the two things that are really important here, okay? And if you remember, opposite over hypotenuse and adjacent over hypotenuse, this is sine of theta, this is cosine of theta, and by the way, just for completeness, I'll throw it up here, opposite over adjacent, that's tangent of theta. Okay, these need to be absolutely in your bones because I use them all the time, and this is not a course in sine, cosine, and tangent. This is a course in physics. So we're going to jump back and forth between these all the time, and we're going to use that right here, right now. You see d sub x? D sub x is adjacent. You see the length of d? The length of the vector d, which I called little d? That's the hypotenuse. And you see this height right here? That's d sub y. So opposite is d sub y. So let's use that. Okay, and then I'm going to rearrange these two right here. I'm going to solve this one for d sub y, and I'm going to solve this one for d sub x. To solve this for d sub y, I just multiply through by little d, and I learned that d sub y is equal to d sine theta. I multiply this one through by little d, and I learned that d sub x is equal to little d cosine theta. Well, I'm getting close to the end of all the things that Knight covered in 3.3. One more little thing. Let's take a look at the situation here if the vector pointed into what's called the second quadrant. Okay, so if you have the plane here, and this is x, and this is y, the normal thing is to number this quadrant 1, this quadrant 2, this quadrant 3, and this quadrant 4. Suppose the tail of a vector is at the origin and it's pointing into the second quadrant. Okay, so suppose D looks like that. That's an interesting situation. The shadow of D dropped down onto the x-axis is now right here. The shadow of D dropped down onto the y-axis is this right here. Now this still goes along the positive y-axis, so this is still what we consider to be a positive number. But notice this one kind of goes, the shadow of this vector onto the x-axis goes the opposite direction that you'd expect, or the opposite direction that's sort of normal. Instead of going towards higher x, it goes towards, the shadow goes towards lower x. Now, this is not a vector, okay? It is just a component, but in this case, we capture the fact that this end of the shadow is to the left of this end of the shadow. The end of the shadow that corresponds to the tip is to the left of the end of the shadow that corresponds to the tail. We capture that by saying that this d sub x here is negative. So, for example, if I actually went up here and measured this shadow, and I got, looks like it's 12.5 centimeters. In this case, we would say that d sub x is equal to minus 12.5 centimeters. That captures all the concepts in 3.3.